Function domains. Our objective here, find the domain of a function. Okay, well, what do we know? We know what a function, we know what a function is. A function is a relation in which each component of the domain, each input value, each x value, corresponds to exactly one component of the range, output value or y value. We're going to be focusing on the domains of our functions. What numbers can go into the function and make it work? So a function's domain is the largest set of real numbers for which the output values are real numbers, okay? This is usually all real numbers. Usually we can put any number we want into a function and we'll get something out. However, we need to be careful when dealing with functions that are fractions and or functions that involve even roots. And usually these are square roots. Okay, why do we need to be careful? Because when we have fractions, we cannot divide by 0. So any number that results in a 0 denominator is not in the domain. It doesn't output anything because we can't, dividing by 0 is undefined. Even roots, we cannot take the even root of a negative number. So any number that results in a negative radicand, remember the radicand is the number under the radical sign. So if you have a number under the radical sign of an even root and it's negative, it is not in the domain. Not to fear, we're going to see how this works in some examples here, but basically what you want to be focused on here is when you see a function, okay, if you've got a fraction, you need to be thinking, okay, the denominator cannot be 0. If you have an even root, you need to be thinking, the radicand, what's underneath the radical sign, has to be 0 or positive. It cannot be negative. Okay, let's take a look. So I've got a few examples for you. Example number 1. We want to find the domain of each of these functions. So the first function is f of x is equal to x squared minus 7x. Well, I don't see a fraction and I don't see an even root. So no fraction, no even root. What does that tell us? Okay, it tells us the domain of the f function here is equal to all real numbers from negative infinity to infinity. And think about it. Is there any number that you cannot put into here and get an output? Okay, anything can be squared, anything can be multiplied by 7. Those two can be subtracted, you'll get something. So the domain is all real numbers. We don't have any fraction here, and we don't have any even root. Okay, so that's going to be the majority of the cases. When you look at functions like this, if they're not fractions, or they don't contain an even root, you don't have to worry about it. The domain is all real numbers. Okay, so let's deal with some that are fractions or do contain even roots and see what they look like. So our g function here says 3x plus 2 divided by x squared minus 2x minus 3. Okay, well, we have a fraction. Okay, let's note that. So we have a fraction. If I could spell fraction. Okay, we're looking for fractions and even roots, and we have a fraction here. So we know our denominator cannot equal 0. Okay, so we want to focus on the denominator and see when it equals 0 because we know that those numbers are not in the domain because our denominator can't be 0. So we want to focus on that denominator, x squared minus 2x minus 3. Well, when is it 0? Well, this is a quadratic. And this is actually a factorable quadratic, and I've already done the math. this is factored as x minus 3 times x plus 1 is equal to 0. So now we can use our zero product property. And we know that x minus 3 is equal to 0, or x plus 1 is equal to 0. So in this case, x equals negative 3 and x equals negative 1. So this denominator is 0 when x is negative 3 and, x is positive 3. I'll bet you all caught that. Mistake on my end. Good catch if you caught it. And so when x is 3 and x is negative 1, that means this denominator is 0, and that's a no-no. Okay, no zeros in denominators. So these two numbers cannot be included in our domain. They're the only two, because those are the only two numbers that make this denominator 0. So our domain of our g function is, well, we can go from negative infinity all the way to negative 1 as we work our way left to right along the x-axis. And then we union that. We can't include negative 1, but we union that with negative 1 up to 3. Again, this is a way to show us negative 1's not included. Open parenthesis, negative 1 is not included. And then again, we union, and we can go from 3 all the way to infinity. So there's our domain. Any number less than negative 1, any number between negative 1 and 3, not including negative 1 and 3, and any number greater than 3 can work. These two numbers cannot work, and that's what this shows us right here. Okay, let's take a look at two more examples. How about one with an even radical? Whoops, wrong piece of paper. Let's go to the correct piece of paper, which is this one. Okay, there we go. Get the correct piece of paper out. Line up my paper so you can see it, hopefully reasonably straight. Okay, our h function says h of x is equal to the square root. That's an even root. We don't have to write the 2 because we assume if there's nothing written, it's a square of 3x plus 12. Okay, well, that's one of our, we need to check things. Fractions and even roots. So we have an even root, and we know that means our radicand, what's underneath the radical is called the radicand, must be greater than or equal to 0. Okay, that has to be, if it's not, we're going to take the square root of a negative, and that does not exist in the real number system. I don't think it exists in any system. So our radicand, 3x plus 12, must be greater than or equal to 0. It can be 0 because the square root of 0 is 0, but it can't be less than 0. Okay, so it can be greater than 0 or 0, but it can't be less than 0. Let's continue. So 3x is greater than or equal to negative 12. So x is greater than or equal to negative 4. So our domain, anything, as long as it's greater than or equal to negative 4, will work. So domain of our h function equals, well, greater than or equal to is a square bracket. We start at negative 4, and we go all the way to infinity, and of course we always enclose infinity or negative infinity with a parenthesis, open or close parenthesis. So anything negative 4 and above will work in the domain. Anything less than negative 4, negative 5, negative 7, negative 1,000, negative 4.1 is less than negative 4, and it won't work. It will not result in a radicand that we can take the square root of. Okay, our last example. Let's combine these things, and I'm going to keep this one. I want to kind of look the one above it a little bit. Yeah, I'll make use of the example above a touch. So our j of x function says 3x plus 2 divided by the square root of 14 minus 2x. Well, we have both a fraction. Whoops, again, I'm struggling with my spelling. And an even root. Okay, so that tells us that the radicand must be greater than 0. Okay, in this case, we had only a even radical, and it was not in the denominator, so we could equal 0. In this case, the radical's in the denominator. So not only does what's underneath the radicand here need to be greater than 0, it can't be 0. Okay? It can't be less than 0 and it can't be 0. So it's restricted to being greater than 0. So that's the difference between these two. A radical not in the denominator, well, we can be 0. A radical in the denominator, we can't be 0. Okay, the radicand has to be greater than 0 because we're in the denominator. So let's take our radicand, 14 minus 2x, and we want it to be greater than 0, can't be equal to. So this is 14 greater than 2x, divide both sides by 2, and I'm going to write it with, the x term is on the left, so x is less than 7, okay? There is our domain in this case, so the domain, and this is a j function. Domain of j is equal to, well, less than 7. So negative infinity all the way to 7, but 7 is not included, because if 7 were to go in there, we get a 0 in the denominator, so there is our 7 not included, open parentheses, negative infinity, comma 7, open parenthesis. So when you're looking at domains of functions, keep on top of fractions and even radicals.